Okay, let's consider the following example from a page on Khan Academy about amino acids, dietary supplements, and the mTOR pathway. So, the mammalian target of rapamycin, mTOR, is a conserved serine-threonine protein kinase that regulates protein metabolism. mTOR integrates intracellular inputs such as BCAAs and growth factors to promote protein translation. Activation of mTOR results in the phosphorylation of a translation initiation protein called eIF4-EBP1. Unphosphorylated eIF4-EBP1 blocks translation by sequestering a different translation initiation protein called eIF4E. This initiation protein is responsible for binding mRNA cap and bringing the messenger RNA transcript to the ribosome. Phosphorylation of eIF4-EBP1 by mTOR causes eIF4-EBP1 to release eIF4E, resulting in the initiation of translation. Okay, so let's consider the first statement. Mammalian target, so we can assume it's present in mammals. Rapamycin, not sure what that is, we can look into it later. And then conserved serine-threonine protein kinase. So serine and threonine, obviously amino acids. Now conserved protein kinases, not sure about those, we can look into it. So what does it do? It regulates protein metabolism. How does it do this? Or what does it mean to regulate protein metabolism in this context? So next key statement is that mTOR integrates intracellular inputs such as BCAAs, branched chain amino acids, and growth factors. Did you know BCAAs and growth factors can be considered intracellular inputs? Well, I didn't. And this results in the promotion of protein translation. So the next key statement here is that the activation of mTOR results in the phosphorylation of a translation initiation protein called eIF4E, so on and so forth. Seems like a generic string of numbers and letters, at least it did to me at first glance. So anyway, moving on to the next statement. Unphosphorylated eIF4-EBP1 blocks translation by sequestering. So sequestering, I didn't know what it meant. I had to look it up and remind myself. So it means like isolation. So by sequestering a different translation initiation protein called eIF4E. So eIF4E is responsible for binding the messenger RNA cap and bringing the mRNA to the ribosome. Now for the final statement, phosphorylation of eIF4-EBP1 by mTOR causes eIF4-EBP1 to release eIF4E, resulting in the initiation of translation. So what this means to me is that eIF4E will continuously bind to the messenger RNA cap and keep bringing the messenger RNAs to the ribosome, resulting in protein translation, but only as long as eIF4-EBP1 is phosphorylated. When it's in an unphosphorylated state, and you can look into what phosphorylation of proteins is. In the unphosphorylated state, it will block the translation by isolating this module, I assume, eIF4E, which will effectively block the initiation of translation. So I also copy pasted the paragraph into Notepad and just split it to show more or less how I would break it down in my mind, highlighting keywords or things I need to look into more. So yeah, hopefully this is at least somewhat helpful to you, and you got something out of it. Okay, thank you.